And we're back. This is going to be an alternative to the part 1 solution, where because we were in a frequency distribution section, it's a good idea to try to do it in a frequency distribution way. And so we have, again, I'll just read the question. Suppose that on a calm day an airplane flies from city A to B at a constant rate of 150 miles an hour. So flies from A to B going this speed, and turns around, goes back to the beginning, but now he's only going 128 miles per hour. And we wanted to know the average rate, so his average speed. So let's set up a frequency distribution where the only thing that's going to be in the frequency distribution is the speed. Okay, so we have our two speeds. We have the 150 mile per hour speed. Let's move that over a little bit. I want to write the unit. So we have 150 miles per hour, and then we had 128 miles per hour. So what's going to be the column over here? Is it going to be distance or it's going to be time? Now, if you remember how to find the mean of a frequency distribution, you're going to be multiplying these two numbers together. All right. Now, I wrote miles per hour like this, miles per hour, but if you come down here, you can write it as miles per hour, like that. So what would you be multiplying to this would be something in terms of hours, right? So then these hours would cancel. So the right-hand column is going to be time. So now I have to figure out how long it takes for each plane to get to where it's going. All right, well, we have a formula, which is distance, speed equals distance over time. Now that's fine, but I want to solve for time, right? I need this column to be my time column. So I'm just going to kind of work with this formula a little bit, and I'm going to cross multiply, so bring the t up, and it's going to end up looking like this. T equals distance over speed. All right, well, in the last video, so hopefully you watched part 1, but we didn't know the distance between A and B, and we just called it D. Now, because the plane goes forward to B, or goes towards B, and then just turns around and goes back, we assume that the distance back would also be D. That's a bad D. Okay. So the D is not going to change. But the speed will, right? Each direction the speed changes. So for the 150 mile an hour one, it's going to be the time will be distance d over the speed, which is 150. And then the 128 mile per hour side, that's going to be the distance over its speed, which is 128 miles per hour. So now I have, this is in hours. Let me write hours. Okay. Ooh, before I go down there, I just want to make one note. This column here is the frequency column. That's the way we've been kind of treating it. And frequency has always been integers, like 1 hour, 2 hours, 3 hours. But this may not be an actual integer. It could be like 1.5 hours, okay, something like that. And for the purpose of this problem, this is going to work just fine. Okay. All right, so how do you find the mean of a frequency distribution? Well, you would multiply across these two. So again, you have 150 miles an hour, but how many hours are you at that speed? Well, you have d over 150 hours going at 150 miles per hour. And then you're going to add that. I guess I don't really need the units here, because all the units will cancel. All right, and then you have how many hours worth of going 128 miles an hour. That's going to be d over 128 times 128. Now here's the problem. Okay, this is where it starts to get even harder, is that the bottom is you would divide by the frequency. And the frequency would be to add up these two, the time column over here. So we are actually adding two fractions together, d over 150 plus d over 128. All right, now it does simplify, but it will take some work. One of the first things that you can simplify is that you can see that these 150s will cancel, and you're left with d. And then over here, these cancel, and you're left with another d. And then the bottom, I'm going to hold off on simplifying this for a second. But if you watch the first video, and at this point I'm probably going to stop so that you can go back and watch it, because then the last 5 minutes of that video is solving this exact equation, we get this. And we needed to simplify this. So then go back to part 1. I believe it's called a complicated average rate speed problem. So then go back to this one, and you'll see how we simplify this. It should be in the last probably 3 minutes or so of that video. We'll be solving this. And what you'll find is that when you're done solving it, you're going to get 138 point, I believe it's 129. I'm not, I wish I didn't have the answer on me, but 138.129 miles per hour.